Assalamualaikum and good morning grade 11. Welcome to our fourth quarter period. This period, we will determine if you're going to be promoted or not. If our you students, I will be give 100% effort to our subject. Our topic for today is all about main group, representative elements. It is a continuation of the electronic structure and periodicity.
First, from the main group, which is the alkali metals, elements belongs lithium, sodium, potassium, rubidium, cesium, and francium. The alkali family is found in the first column of the periodic table. Alkali metals are found in group 1A or 1. Atoms of the alkali metals have a single electron in their outermost level. In other words, one valence electron. To complete the stable valence electrons, alkali metal family needs 7 more valence electrons to complete the stable valence electrons. Also, alkali metals, they are the most reactive metals. They react with water to release hydrogen gas. Alkali metals are never found as free elements in nature. They are always bonded with another element. In other words, alkali metals need more other elements to be bonded. Next up, alkali earth metals. Elements belong to this group will be beryllium, magnesium, calcium, strontium, barium, and radon. Alkali earth metals, they are found in group 2A or 2. They have 2 valence electrons. They are very reactive but not as much the alkali metal. This group, they need 6 valence electrons to complete the stable valence electrons. Third main group, which is the boron family. Boron elements is the representative of this group. The boron family is named after the first element in the family. They are found in group 3A or 13. Atoms in this family have 3 valence electrons. The elements belong to the group are boron, aluminum, gallium, indium, thallium. This family need 5 more valence electrons to become a stable. But before we proceed to the carbon family, did you understand, class? Very good. And now, let us proceed to the carbon family. Atoms of this family have 4 valence electrons. They are found in group 4A or 14. This family includes carbon, silicon, germanium, tin, and lead. This family needs 4 valence electrons to complete the stable electron. Let us proceed to nitrogen family. The nitrogen family is named after the element that makes up 78% of our atmosphere. They can be found in group 5A or 15. Atoms in the nitrogen family have 5 valence electrons. They tend to share electrons when they bond. So this family, they shared their valence electrons to the needed family. Other elements in this family are phosphorus, arsenic, antimony, and bismuth. And also, they need more 3 valence electrons to complete the. And now, let us proceed to other family, which is the oxygen family. Atoms of this family have 6 valence electrons. They belong to group 6 or 16. Most elements in this family shared electrons when forming compound. This family includes elements sulfur, selenium, tellurium, and polonium. This family always shared their electrons when forming compound to other elements. And now, we have also the halogen family. The elements in this family are fluorine, chlorine, bromine, iodine, and astatine. They can be found in group 7A or 17. Halogen have 7 valence electrons. They need more 1 valence electrons to complete the stable electrons. Before we proceed to another family, any questions, students? Oh, very good. And now, let us proceed to this family, transition metals. Transition elements include those elements in the B families. These are the metals you are probably most familiar: copper, tin, zinc, iron, nickel, gold, and silver. They are good conductors of heat and electricity. Transition metals also, the compounds of transition metals are usually brightly colored, are often used to color paints. Transition elements have 1 or 2 valence electrons which they lost when they form bonds with other atoms elements. And now let us proceed to noble gases, which is the complete valence electrons. Noble gases are colorless gases that are extremely unreactive. One important property of the noble gases is their inactivity. They are inactive because their outermost energy level is full. Because they do not readily combine with other elements form compounds, the noble gases are called inert. The family of noble gases includes helium, neon, argon, krypton, xenon, and radon. All the noble gases are found in small amount in the Earth's atmosphere. And also, noble gases are the complete set of valence electrons, which is 8 valence electrons. Noble gases family are found in the right side of the periodic table of elements. And we have also the rare earth elements. The 30 rare earth elements are composed of the lanthanide and actinide series. One element of the lanthanide series and most of the elements in the actinide series are called transuranium, which means synthetic or man-made. This is the illustration of the periodic table of element that you can see the alkali metal, the alkaline earth metal, transition group, boron group, and etc. And now let us proceed to collectron configurations in the periodic table of elements. Elements belonging to the same group have the same number of valence electrons. And also elements as belonging to the same period have the same numbers of shells. The S, P, D, and F blocks of elements are easily differentiated from one another because of differences in the number of their outermost electrons. The first 2 columns to the right of the periodic table fill up the ns orbitals and are referred to as s blocks element. Do you understand, students? Very good. The last 6 columns fill up the np orbitals and are called the p block elements. Between the s block and the p block elements are 10 columns which fill up the n-1 d orbital, and these are the d block elements. On the lower part of the periodic table are 2 series of elements which fill up the n-2 of our f orbital and are called the f block elements. Did you understand where do you found the blocks of the elements, students? Very good. These are the illustration. Let us proceed to predicting periods and groups. The period and groups of an element can be predicted from the electron configurations of that element. The following guidelines can help in determining the period and group of an element. Line number 1. If the electron configuration of the element ends in S or P, then the element belongs to family A, Otherwise, the elements belongs to family B. Line number 2. The outermost energy of the element corresponds to its period. Guideline number 3. For an element belonging to family A, the number of electrons in the outermost energy level corresponds to the group of the elements. For an element belonging to family B, provided that the electron configuration does not end if the total number of electrons in the outermost energy in level and the incomplete inner sublevel is equal to the group number except for the following sums whose corresponding groups are indicated. This is the example of how to write electron configuration. For example, calcium. Calcium have atomic number of 20. So that start from 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. The total number of 20. Please remember, class, that we always start from the S block elements. Now, let us proceed to trends in the periodic table. What is the new on the periodic table and what are the discoveries from the periodic table of elements? But before we proceed to the trends in the periodic table, let me know what is your question about the lessons. None so far. So very good. Let us proceed. Periodic trends are specific patterns that are present in the periodic table that illustrate different aspects of a certain element, including its size and its electronic properties. Trend, which is atomic size, usually expressed as an atomic radius measured in picometers. Atomic radius is equal to half the distance between the nuclei of two atoms of the same element when they are joined. Meaning, atomic size determined the radius when the two elements are combined or joined together. This illustration, the atomic radius of hydrogen 2 P determined the radius of the two hydrogen. Also, atomic size increases as you move down a group. Going down a row adds other energy level of electrons. Also, atomic sizes decrease as you move from left to right across a period. Moving from left to right, there is an increase in protons, causing greater attraction to electrons. Second trend is ionization energy. Is the energy required to remove an electron from atom. Shielding effect. When inner electrons block the positive change from outer electrons. Ionization energy tends to decrease down a group in the periodic table. The farther the distance of an electron from the nucleus, the more easily it can be removed. These are the periodic table of the elements. Our third trend is electronegativity. Is the ability of an atom to attract electrons to itself. Electronegativity decreases from top to bottom and increases from left to right of the periodic table of elements. Fourth trend is electron affinity. It is the amount of energy released or exerted when an atom gains an electron. The electron affinity of an atom can be described either. On a group, the electron affinity of the elements decreases. Electron affinity increases within the periods. The last trend is the metallic property. Within a period of the periodic table, the elements become more non-metallic from left to right across a series. Within a group of from top to bottom, metallic properties will increase. Illustration of the periodic table trend, atomic properties, and the periodic table summary. Your assignment